Hello folks, my name is Andrew Osipov. I'm the principal engineer here at Cisco Security Business Group. My job at Cisco is real fun. I get to design next generation security solutions, architectures, and features. And one of the particular innovations of recent is our brand new Firepower platform family. Now, if we were to talk about the entire family, all the different features, hardware and software, it will take us a very long time. But today I want to cover just one feature which to me seems really cool from the innovation perspective. And the feature is called Flow Offload. So before we start talking about what Flow Offload does on the platform, let's set the use case. Why do you need something like Flow Offload? Consider something like a database cluster in your data center. So you have several of your database servers that are doing perhaps some kind of a bandwidth-intensive synchronization procedure, perhaps a backup, to a different set of servers, typically on a different data center segment. Now, if you are careful about security, like most customers would today, you would want to place some kind of a stateful firewall in between those different segments. Basic east-to-west security, you typically go with a firewall, maybe a next-generation IPS, maybe a threat-centric security solution like our Firepower Threat Defense. Now, you put the firewall in there to provide security between those two different data center segments. Well, now you establish all those connections that are doing very high bandwidth intense data transfers. Now, one thing you have to keep in mind, in order to provide any kind of meaningful threat-centric security on a firewall, you have to do things in x86. Now, you can offload certain things into hardware. You can try manufacturing your ASICs and FPGAs to support all the current protocols, current attacks, new protocol, new attack signatures, everything that can possibly be anticipated, but it's not very realistic. In order to do this thing at scale and truly get protection, you have to do things in x86 where the code operations are very easily extendable. As new protocols are added, you can quickly add those protocols as software features. If new threats come up, which happens all the time, you can also very quickly implement them in x86. Now, since you're doing things in x86, obviously that gets a little bit more computationally intensive. And as you implement different functionality like next-gen firewall, next-generation IPS, perhaps advanced malware protection, which is one of the coolest features of our Firepower and Firepower Threat Defense products, as you go down the stack, you are starting to inspect packets at a great depth. And now, if you look at stateful protocols like TCP, and then maybe something application level like SIP, and FTP, and many other protocols that need to be inspected very, very deep down to the application level, you'd notice that you'd want to keep every single packet for a single connection, single session, to a single processing instance. And a processing instance is typically a CPU thread, which is running, say, a data plane process, which will examine every single packet for those types of connections. And it's very important to examine every single packet for a connection in one of those processing instances. So essentially, you are doing it on a single x86 CPU core. If you were to try to do it in parallel on two different cores, you'll have a situation where some packets go through one CPU core, some packets go through a different one, and the state has to be tracked independently, and then you don't get the full benefit of threat-centric security. So here, you're doing things in x86. You want to also do all the security functionality on a single x86 CPU thread. And here you have all those high bandwidth flows which happen every night, perhaps the same time, doing the full database synchronization or backup from one segment of your DC to the other. So you have gigabits of traffic passing through those flows. We have customers passing between 10 and 20 gig through each of those different flows. Now, doing 10 to 20 gig of deep packet inspection in a single x86 CPU thread for something that's implicitly is trusted, and you shouldn't be backing up something that's already not clean since it's got into your data center, and you hopefully used one of our threat-centric products across all the different segments. Well, doing this inspection on those trust flows is very inefficient, and you're not probably going to get even to 20 gig of single flow processing, as we call it, with that kind of architecture. Now, another use case, that's one use case. The second use case is a real-time application. So you have something like a stock exchange, perhaps, and you have a bunch of trading stations which feed stock quotes of that exchange. So these are your stations here, right? So trader 1, 2, and 3. And literally, in this type of installation, time is money. The quicker you get the stock quote from the stock exchange to the trading station, the quicker you can react, the quicker you can make money, and you can effectively avoid loss if something happened in the market and you have to put some orders, buy or sell, in place. Now, this is where the bandwidth is not as important, but latency, low latency, is extremely important. So you want to do something we call a microsecond latency. Not so in like 100 microseconds, it is as low as possible, because again, time here is money. Again, if you were to stick the firewall in between those flows here, you are faced with a situation where, while you do all this deep processing on something that's not probably going to contain many threats because you have other security measures in place, well, the firewall will slow things down to a degree and your latency is going to go a little bit higher. So again, in both of those cases, you want to have some form of expedited processing within the firewall to get those fat flows. We call them fat flows here, those big data center flows, fat flows or super flows, and as those low latency flows, get them through as quickly as possible. So what some other vendors do in those cases? Well, a common approach is to build a switch into your firewall here, and then for certain kinds of traffic, it just goes directly to the switch. You don't get any security, you don't get any visibility. The x86 here does not see anything. It all gets offloaded into hardware. You offload and forget it. And this way you churn things quite fast because it is hardware, it is a switch, but on the other side, you're not getting much of the security benefits. So then the good question is, why even have a firewall in place? So let me talk to you about what we do in our Firepower appliances to implement flow offload for this use case. So on the Firepower platforms, we have a special module that helps the x86 CPU complex with a basic network-centric task. So here we have your x86 complex on every module in Firepower 9300 and the module that is embedded into the Firepower 3100. So your x86 module is still doing threat-centric security. So this is your threat-centric engine running normal firewall, normal NGIPS, AMP, all those cool things. But traffic on the way to x86 internally to the module passes through this special module we call SmartNIC. So this SmartNIC can process traffic on its way to x86 complex and potentially make some decisions locally without having to involve x86 at all. And that's the basic premise behind flow offload. So as packets come into the SmartNIC, what is the first thing that happens? So you have a new packet, new connection potentially coming in. So SmartNIC has this special module called the classifier. So it looks at the packet and checks if the connection actually is supposed to be processed in hardware. And for any new connection, any non-trusted connection, it will not find an entry, it will send it to x86. And x86 is going to process it and send it back out normally, as again, any kind of firewall normally would. Now at some point, the main threat-centric engine may decide that it's time to offload this connection into hardware. Maybe it's one of those trusted flows that you really want to accelerate. Maybe x86 engine decided that it has extracted every single bit of security context out of this connection, and further inspection is not really useful based on the configured policy, based on the threat context of the flow. So it will tell the SmartNIC, it will say, hey, you can now process that connection in hardware. So when the next packet comes into the SmartNIC for this particular connection, the classifier is going to find a match. It's going to say, well, hey, the x86 complex told me that I can offload the processing of this connection into hardware. So it has this hardware module which will locally process this connection. And the cool thing here is, right, we said that building a switch, a simple switch that will just shortcut packets through the box to the firewall is not good enough, right? We want to provide a little bit more in terms of security. It's not going to be your entire threat-centric feature set, but it's going to be better than just a switch. So this special hardware module is going to do things like TCP sequence number randomization. So it's going to do that. It's going to do NAT and PAT rewrites. So it will change the IP addresses and ports in the packet based on your NAT and PAT policy. It will also keep track of byte and packet count. Basically, all the things that you are getting on the firewall as far as connection tracking, since the TCP sequence number progression checks, will still happen. So sequence number, NAT path rewrites, byte and packet tracking. And another really cool thing here is that it will continuously update this information, the stateful record with bytes and packets, to the main threat-centric engine. So it can know what is happening with the flow at any given point in time, and if necessary, it can also send out NCEL updates, NetFlow, secure event logging, which could be consumed by Cisco StealthWatch. And that is a whole different talk on its own, what cool things you can do with StealthWatch in terms of detecting attacks, in terms of knowing what you have happening in your network, even based on this simple data. Source IPs, destination IPs, byte and packet counts in each direction of the flow. You can do really amazing things with that data with StealthWatch. So all that is being continuously synchronized in real time to the main x86 processing engine. And another cool thing is, at any given point in time, based on all this data, x86 can tell the SmartNIC and say, hey, we are done with offload. I want to look at this flow again, so quit offloading. I want to see packets for this flow. I want to see what is happening. And the SmartNIC will start forwarding packets not through the hardware engine, but through the x86 path. Even if you don't do that, the SmartNIC here, yes, it doesn't do full-blown TCP state tracking, but it knows TCP SYN from a FIN, from a reset, so it can do this, right? Differentiation SYN, FIN, reset. It can detect those different types of control flags and then do things based on that, redirect them back to the x86 or make decisions locally. So that's really how Flow Offload operates. So what does it give us in terms of performance? So with Flow Offload Active, we can do 21 gig of TCP single flow throughput, and that's not really our limitation. That's how fast our traffic generator could go with TCP. So single flow, right? Single flow, you're getting 21 gig of TCP throughput. We measured 39.7 gig in a single flow with UDP, right? You can go line rate with 40 gig interfaces, UDP, a single direction. As far as latency goes, with 64-byte UDP packets, we measured 2.9 microseconds of latency, which is great for your real-time trading applications, because now that's really industry-leading figure as far as latency goes. So all those different things Flow Offload gives you in terms of performance. At the same time, you're not losing visibility. You still have your basic security functionality, basic state tracking, NAT and PAT, TCP sequence number, randomization all happening, and then you get the visibility into the flow through NCEL on the main x86 firewall engine as we go along. So that is Flow Offload. Again, a very cool feature in our Firepower 4100 and 9300 platforms. This is Andrew Osipov, and thank you for watching.